Okay, so this is to continue on where we left off with polar numbers, going back and forth from complex numbers to polar form and polar form back to complex numbers. Some people think this is, I don't know what the deal is with these, but some people think this is hard. And really, if I gave this to you 3 weeks ago, or if it was on an SAT and you had to know how to do it, I would hope that you would figure out that you should take, like, for example, this first one, cosine of 2 pi over 3 and sine of 2 pi over 3, and then multiply in the 4. So the cosine of 2 pi over 3 is 1/2. Let me see if I have my pen on. I don't. So the cosine of this is 1/2. We are in the second quadrant, though, and cosine is negative, so it's negative 1/2. That's going to go away here in a minute. I have to go back and put it in. And put the I. Sine of 2 pi over 3 is square root 3 over 2. In the second quadrant, sine is positive, so we will leave it that, and then we will distribute that 4 into both of those things. 4 times negative 1/2 is negative 2, and 4 times that is 2 square root 3 I. Sometimes you'll see the I in different places just so that it doesn't look like it's underneath the square root sign, but I think your book likes to put the actual number part, the 2 square root of 3, before the I. Okay, same thing on the next one. Cosine of 7 pi over 4 is square root 2 over 2. In the fourth quadrant, that is, oh, that was kind of fancy, positive. Cosine is positive, and this is negative times 3. So this would be 3 square root 2 over 2. Plus, I'm going to change it to a minus sign to deal with that negative. 3 square root 2 over 2i. And you would see it written like that. So find what they are based on the unit circle, and then distribute that r into both of them. Okay, the next thing we're going to do is multiply and divide complex numbers. This is just a simple way, especially if they're already in polar form, to multiply complex numbers and to divide them. If they weren't in polar form, honestly, I would, if it's just 4 plus 3i times 2 minus I would just multiply them out and go from there. But if they're in complex form, not complex form, polar form already, I would use these formulas. So when you're multiplying 2, that's what this is trying to say right here, is you're multiplying 2, you multiply the r's, and then you add the angles. If you're dividing, you divide the r's, and then you subtract the angles. So if you're curious as to why this is, let me do a quick proof of that first one. So we have two complex numbers, R1 cosine theta plus I sine theta. I'll call those theta 1 times R2. There should probably be another bracket inside here. R2 cosine theta plus I sine theta. And that's some second number. I can pull these out, the R1 and R2, because there's 4 things getting multiplied here. 1, 2, 3, 4. So there's 4 things getting multiplied. I'm going to pull the R1. I don't know why the computer likes to do this. Sorry for how sloppy this is. And then you have cosine theta 1 plus I sine theta 1 times cosine theta 2 plus I sine theta 2. Now, just like if they were complex numbers, you can multiply those out. So we'd still have that R1, R2 out in front. And then all of this, you would have cosine theta 1, cosine theta 2, plus, I think I'm going to put the I out in front, I cosine theta 1 sine theta 2, that's the outside, plus I sine theta 1 cosine theta 2, plus I squared sine theta 1 sine theta 2. That's a theta. Hopefully all of you remember that I squared turns into -1, so that becomes -1. And I'm going to group these by I terms and non-I terms. Hopefully I have enough room on this slide. We have R1, R2, and then when we group these things together, come on, why is the pen being weird? Cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. If you look at this, cosine, cosine, sine, sine, all of this turns into the cosine goes cosine, cosine, sine, sine. That's really why I wanted to show you this proof, is because it goes to my favorite song and my favorite proof. I do not know why my pen is doing this, and it's really bothering me. Oh, seriously. R1. R2. This turns into the cosine of the sine, stays the same sign in the sine. It switches in the cosine, so it would be theta 1 plus theta 2. And then over here, we'd have the same thing, plus I. And then when you group all these together, you get, this is getting really ugly and messy. I apologize, but I kind of just wanted to show you that this really does apply to something else that we've talked about in the past. Cosine 1, sine theta, plus sine theta 1, cosine. The sine goes sine, cosine, cosine, sine. So this all gets replaced with sine of theta 1 plus theta 2. In the end, it goes back to this formula. Let me erase all my marks here quickly. Whoops. You multiply the r's, and then you add the angles based on the cosine, cosine, sine, sine. So you could go ahead and do FOIL and multiply it all out, but these are just supposed to save you a little time. Okay, moving forward, we have these two numbers in polar form. Remember, your book is probably going to write them out as 7 cosine of 9 pi over 8 plus I sine 9 pi over 8. Just seems silly to me. Especially when you're going to write cosine plus I sine every single time. So what this formula says that you do is it says you multiply these r's. So 7 times 2, 14. And then it says you can add the two angles, 9 pi over 8 plus 8, or pi over 8. That's 10 pi over 8. And 10 pi over 8 is 5 pi over 4. It's just an easier way to multiply numbers when they're in polar form. Same with division, but you can divide them. Divide the r's, 7 divided by 2, and then you subtract the two angles. 9 pi over 8 minus pi over 8 is 8 pi over 8, and that is pi. Okay, the next one is cosine plus I sine pi over 4, 3, and cosine 3 pi over 4 plus I sine 3 pi over 4. Like I said, I really like this abbreviation. I wish more books used it just because why rewrite it all the time? Okay, so we're going to multiply the r's. The r's just happen to both be 1, so it's going to be 1. You add the angles. Pi over 4 plus 3 pi over 4 is pi. Done. And the only thing you have to watch out for is what happens on this next one, 1 divided by 1. And when you subtract these angles, you get pi over 4 minus 3 pi over 4. That's negative 2 pi over 4. But negative 2 pi over 4, I could probably reduce to negative pi over 2. However, all of your books are going to have your answers, and everything that you're going to have to do is going to have you write your answers with angles between 0 and 2 pi or 0 and 360. So you can't leave your answer like that. It's going to have you rewrite that. Negative pi over 2 is the same thing as 3 pi over 2. Okay. If you have any questions, let me know. And I think that's it for the week. Good luck.